Why do we want to learn Adobe Illustrator? And how is it different from Photoshop? What are its uses? We're going to try and answer some of those questions in this video, and also to learn a little bit about how computer graphics started. It helps to go back to the era of the 1970s and the 1980s and look at what high technology was then. If we wanted to watch a movie at home, we had the fabulous new Betamax or VHS VCRs that we could get tapes and watch them on. If you wanted to listen to music on your own through a pair of headphones, you could get a cassette tape and put it into your high-tech Sony Walkman. If you wanted to take a picture, you had to get a film camera, load it up with a roll of film, shoot the roll, and then have that developed and printed with wet photographic chemicals. Video games were just getting started out. If you wanted to see a movie, you went to the fabulous Cinerama Dome in Hollywood, where you would see the latest of high-tech projection. Not very many people could afford them, but camcorders existed for on-the-spot video recording. And of course, cell phones were just coming into existence, or satellite phones. So this is sort of the environment that computer graphics started in, and we never dreamed that all of these devices would eventually be condensed into just one little phone like the one we all carry today. So it is pretty interesting to look back and see how it all started. In the 1970s, starting in the early 1970s, Xerox had a research lab, the Xerox PARC lab in Silicon Valley. And they were the first ones to develop the idea that you could look on a computer screen and actually see something similar to what your output was going to be. And this was a very new idea. Before that, in early word processors, if you wanted, for example, to make type bold, you would just type a code in, and you wouldn't see anything on your screen that looked like what your output was going to be. So it really took programming and computer science to even operate any kind of a computer. So the people at Xerox PARC had this great idea that if they could develop a system with a big screen and you could see on the screen something similar to your output, that would be really cool. And of course, history has proved them right. However, they had a limitation, which is that they had to work with raster technology, which was at the time called bitmapped. And it was made up of a grid of square pixels. And we still work with this technology today, although we don't use it for type anymore. And you can see the reason for that if you look at this R right here. You can see that square pixels do a great job on the straight vertical and horizontal lines, but they didn't do such a great job on the curves and the diagonals, which inevitably would give you a stair-step look. And their early efforts to show type were a little difficult. You can see that italic was almost unreadable, and the type looks very, very crude by today's standards. And because of the limitations of bitmap technology or raster technology, if you wanted to have a typeface in multiple sizes, like here we see cream 10 and cream 12, what that means is that they had to have separate files in each size. So say if you wanted Times Roman, you would have to have separate files for 9 point, 10 point, 12 point, and etc., because raster type did not scale. So it was awkward, but it worked, and people were just very excited to see this technology because nothing like this had ever been possible. And this over here on the right was the Xerox machine that they developed, their research machine. And you can see it's something of a monster. It's a great big thing. It does have a mouse, which was kind of a new thing. The mouse looks more like a bar of soap. It had a screen, which would have been a black and white screen. And Apple engineers, led by Steve Jobs, who was starting a little computer company at that time, arranged to go visit Xerox PARC. And I believe they allowed people to buy some stock or something to pay them back for this privilege. And they saw this and they decided to try to make a consumer level system, which eventually has become the Macintosh we're all familiar with. Xerox eventually did try to commercialize this technology quite a bit later, but they went for the business market that they were accustomed to and were selling large office systems with multiple workstations, storage, laser printers for something around $100,000, and that never really caught on. What did catch on was the Macintosh, which was introduced in 1984 and one of the first consumer level computers to have the graphic user interface, which meant that what you saw on your screen bore a resemblance to what you would output. And looking back on this computer, which was so high tech at the time it was introduced, it's kind of hard to comprehend by today's standards. For example, this little black and white screen was not too much bigger than a postcard. The original Macs had just a floppy drive disk, and on that little 400K disk would live your system, your programs, and all of your files. Eventually, the idea of having external disks came along, but nonetheless, as primitive as it looks to us today, this was a revolution in what you could do with personal technology. Now, the original Mac cost $2,495. It had 128K of RAM. And that sounds like a reasonable price, but you have to kind of realize it in context. In 1984, the minimum wage was $3.35 an hour. And it took a lot of hours of work to buy a Macintosh. Nonetheless, people did it. The early Macs had to use raster technology that we've just looked at to render type, and they still had to live by the difficulty that if you wanted to have big type, you had to actually have a separate file, a separate little mini program for each size of type. However, this idea of having multiple typefaces on a consumer level computer was very, very exciting to people. And I don't believe that Steve Jobs and his engineers had any idea that they were going to revolutionize the graphic design business. But that's what happened. And as often happens when users got their hands on this technology, as crude as it was by today's standards, they started doing all kinds of things that the original engineers had never imagined. Once again, recall that in this time, digital cameras didn't exist. Scanners were for high-end professionals, and the only printers that an ordinary person could hope to afford were these little impact printers that used raster technology. They seem crude by today's standards, but I still remember my first image writer and how thrilled I was to be able to use different typefaces. So moving on, we're going to think a little bit about the technical history of type. And from the invention of typography in the 1450s in Germany, up until the late 1970s, 1980s, type was all cast in metal. And believe it or not, in those days, if you wanted to print a book or a magazine or a newspaper, you had to, one way or another, set your text in metal type, cover that type with ink, and impress it into a piece of paper. And this is a type case, and it shows a different little compartment for each one of the letters that could be hand sorted into a type stick here by a typesetter. And you can see this guy looks kind of tired and a little hunchbacked. I'm going to guess his feet hurt. He stood there all day hand composing type. And when he would be done, they would put each letter back into its little compartment and start all over again. So printing was a very expensive, meticulous, and time consuming process, and also, of course, required a great many physical resources. So it's so different from today, it's kind of hard to imagine. In between digital technology, which is what we use, and letterpress, there was a interim technology called cold type, photographic type. And this did not have the beautiful, sensual quality of lead type as it pressed into paper, but it was a whole lot faster and cheaper. And phototype pretty much displaced lead type in the 1970s and early 80s for most uses. And we had at that time something called paste up, where the photographic images would come off of the CompuWriter, and you would cut them up and paste them up and send them to be photographed and used for offsite printing. There were some limitations to this technology, one of which is that typesetters had to retype all copy manually when entering their coding for the formatting. So you'll notice that we have a keyboard here, and up here, if you see this kind of panel here, that's where the typed copy would go that a typist had typed out, and the typesetter would have to retype it. So this is something we can't even imagine having to do today. Imagine how it would have been for a book of several hundred pages that had been typed once. It would have to be typed all over again to be typeset. Nonetheless, with all its limitations, cold type or phototype was a whole lot faster and cheaper than lead type, and so it became the standard. Oops. Jumping ahead, and looking at the early Macintoshes, they were limited by Raster technology, and programs such as MacPaint and MacWrite, which was a word processor, inspired a generation, really, of graphic artists to paint on the computer. And this is an effort by an early artist named Susan Kerr, who was quite an expert in MacPaint. And again, you can see that by today's standards, these programs are very simple, and yet it was so exciting for artists to be able to do things that could be easily reproduced and cut and pasted into word processing documents. And the technology that they used was called Quick Draw for the pictures. I don't think we use that at all anymore. What happened next was another unintended consequence of technology development, that a French engineer named Pierre Bézier, and there he is, had developed in the 1960s a vector technology to describe perfectly curves and shapes. And his intention was to make it easier to engineer automobiles. He worked for the French manufacturers Citroën and Renault, and he developed vector technology just as an engineering tool. And of course, it was a tremendous tool because it meant that once, say, something like a screw or a part had been described in this vector technology, it could be infinitely copied and edited. And this made a tremendous savings in manufacturing and engineering. However, it didn't stop there, because what happened is a computer scientist named John Warnock got wind of this vector, had discovered this vector technology. His wife was a graphic designer, and he thought that perhaps vector technology could be adapted for art. This was kind of a crazy idea, but this was the beginnings of the company Adobe, founded by Mr. Warnock and several others. So Adobe's first computer graphics program, Adobe Illustrator 1.0, was introduced in 1987. And for artists of my generation, it was the first program we all learned. You might say, why didn't we learn Photoshop first? Well, Photoshop wasn't introduced until 1988, so it came a little bit later. And Illustrator introduced this radical new vector technology, and Photoshop refined and perfected the existing raster technology. And Photoshop caught on so greatly that soon Photoshop would become a verb, and it's a verb that we're all very familiar with. To understand some of the differences between the uses of vector and raster technology, we'll look at how it's used today. In Adobe Illustrator, shapes are defined by Bezier anchor points and paths. And in Photoshop, the shapes are designed by a pixel grid, defined by a pixel grid. And there are other programs that use these technologies besides the Adobe programs, but Adobe programs are at present the industry standard. However, there are free or less expensive programs that use these technologies, and here's a little list of them. And I think you might want to try those out if you don't want to hand your credit card over to Adobe, which is quite understandable. What vector technology did that was so revolutionary was it allowed the crisp rendering of logos, type, and all kinds of corporate identity information. And even today, logos and type are exclusively done in vector technology. Icons are generally designed in vector. And some of the advantages of vector technology are the small file size and the infinite scalability. Photoshop continued to develop and perfect the ability to represent and edit continuous tone photographs. And some of its limitations were resolution dependent, that if you enlarged a rasterized photograph, you would start to see the pixels. And that if you wanted a high resolution or a high level of crispness in a raster file, a large file, you ended up with a large file size. However, these two technologies work hand in hand. Nobody can really call themselves a complete graphic artist if they're not able to work with both. Once again, the limits of raster technology was that stair-stepping, although a technique called anti-aliasing was eventually developed to try and soften that with gray pixels that do make it less noticeable, but still nothing like the kind of level of crispness that vector type can offer. Looking at vector type and how it's described with a series of anchor points and paths. And the anchor points can have control handles that allow you, as we'll be doing as we move into learning Illustrator, allow you to infinitely manipulate your shapes. Raster type or bitmap type still maintained its limitations. So once vector technology came into wide use, type all switched over to vector, and it is still all done in vector. So once again, the uses of vector and raster are logos, icons, and hard-edged illustrations are much better done in vector or Illustrator format. And one of the great advantages is that if you design a logo in Illustrator, it can be enlarged to the size of a billboard or the side of a building, and it'll be just as crisp and just as fine as the smaller version. The day-to-day work of a graphic artist requires us to work with a great many files of different formats, and you'll find it quite helpful to start memorizing the various file extensions and to learn what program, and whether they are raster or vector. Just a little quick primer on that is the native Adobe Illustrator file format is .ai. Related formats are PDF, portable document format, we're all familiar with, EPS, which is very similar to the Illustrator format. We don't use that so much more anymore. SVG, which is scalable vector graphics, and that is a compact universal vector format, which is often used for icons or for vector drawings that need to be animated. Not so much used anymore as SWF or Flash, which is outdated because it does not work on mobile devices. Common raster file extensions you may encounter are the native Photoshop file format, PSD, TIFF, which is a generic file format, JPEG, Joint Photographic Experts Group, is a compressed format, which means that every time you save a JPEG format, it gets compressed and it loses a little bit of quality. And when you need to work with transparency, for example, for logos, if you don't want a white background, GIF or GIF, as some people call it, supports transparency, and PNG supports transparency. So it's good to study these different formats and get familiar with what their advantages and capabilities are. So now our task is to learn to actually use Adobe Illustrator so that we can create wonderful vector illustrations, logos, type, and icons. So let's get started with that.